Let's take a look at Leetcode 198, the house robber. Let's imagine yourself as a robber, and what you do is basically robbing houses. So let's say we have a different houses on a street, and the number here represents how much money each house has. And as a smart robber, you don't rob houses that are next to each other. So in this example, you can rob house 1 and house 4 and house 7. In this case, the maximum money you can rob is 12. Or you can rob house 2, house 5, and that's it. So in that case, you get 7. And in this particular example, 12 is the maximum you can get. So let's use a list of integers to represent the houses on the street, and each number represents how much money is in that house. So a naive approach would be to try out every single possible combination, which will have a complexity of 2 to the n, where n is the number of houses, as for each house you have basically two different options, which is rob and not rob. So a better approach would be to use dynamic programming. Let's say you use di to represent the maximum amount of money you can rob from index 0 to index I. So when I is 0, d0 equal to I. When I is 1, di is equals to 2 in this case, because you can either rob the first house or the second house, and the second house has more money. And when I is 2, when we add the third house, d of 2 is actually equal to the maximum of d of 0 plus 4 or d of 1. Basically, what it says is that you can rob the third house and combine the amount with the amount you have robbed till house 1, or you can choose not to rob the third house and just keep what you have robbed so far till house 2. Therefore, we can write the inference function for our dynamic programming. So d of I equals to the max of d of I minus 2 plus hi. Hi stands for the money in a house at the i's index, and d of I minus 1. So let's see how it is being translated into code. So here we have the rob function where it takes a vector of numbers. So when the vector is empty, it means there's no house. So we just return 0. And when n equals to 1, means there's only one house, and we can simply just return the money in that house. If n equals to 2, meaning there are two houses, since we cannot rob houses that are next to each other, so we just return the larger value out of the two. And we have this dp vector, which stores the maximum amount of money you can rob from house 0 to house I, as we discussed before. So when I is 0, dp0 is equal to the value of the first house. Similarly, when I is 1, we take the larger value from the first two numbers. Starting from I equals to 2, we can use the inference function we derived before to calculate the dpi from I equals to 2 to I equals to n minus 1. And eventually, when we get out of this loop, dp n minus 1 will have the max money from house 0 to house n minus 1. So to summarize, instead of exhaustively list all the combinations to get the maximum money to rob, we use dynamic programming to incrementally compute the maximum amount of money to rob from house 0 to house I, and we used a vector to store the maximum money to rob for different I values. And for each value of I, it depends on I minus 2 and I minus 1, meaning we either rob the current house and take what we have robbed from house 0 to house I minus 2, or we do not rob the current house and take what we have robbed from house 0 to house I minus 1. And with this derived inference function, we can effectively fill up this vector bottom up and eventually get the maximum money to rob from house 0 to house n minus 1.